Assalamualaikum. Alright, in this video we are going to look at some examples on solving the area using the finding area using the integration. Alright, so let's look at these three examples here. Alright, so the first example we are given with this graph where we have two functions where it is bounded, the area is bounded by the region is bounded by the function y equal to x squared and also y equal to 4. Right, so firstly we have to find the coordinates of a and b. So to find the coordinates of a and b, what we should do is to equate these two equations. Right, so these two functions here, so we have to equate them. Right, so because y equal to x squared will meet with the y equal to 4 at both a and b, so we'll take this x squared is actually equal to 4. Right, so we have that x squared equal to 4, so x will be equal to plus minus 2. Right, so meaning to say that it is a negative 2 here and also positive 2 here. Right, because we want to find the coordinate, so we have to find the ordinate of y. So how do we find that? We know that it is 4 at this place, so meaning 4 here, so the coordinate for y is actually 4. So we have that a is equal to negative 2, 4 and also 2, 4 for b. Alright, so that's as simple as that. Alright, so you have to write properly. A is equal to negative 2, 4 and b is actually equal to 2, 4. Alright, so that is the first question. Now we have to find the area of that region R. So we should note that the area is bounded by the, right, so we have that the one at the upper parts here is actually given by y equal to 4. Right, so the one at the lower parts here is actually this what do we call y equal to x squared. So this one should subtract this one. Right, so we have the function. All right, so to find the area, right, so now we are going to differentiate with or integrate with respect to x. So it is from negative 2 until 2, negative 2 until 2. Why? Because the region is bounded from this place, from this until this. All right, from negative 2 until 2. So now we are going to substitute with the upper function. The function at the uppermost is actually 4. So 4, we have to subtract the one at the lowermost, which is x squared. So we have to subtract with x squared, and it is dx because we integrate this with respect to x. So what we need to do is to find the definite integral for this one. So we have to integrate that to be 4x minus x to the power of 3 over 3. That one is from negative 2 until 2. So what's need to be done is that we have to substitute with the value 2 and then negative 2. So firstly we substitute with 2, so we'll have something like 2 to the power of 3 over 3. That one is for the first part. We have to subtract with the one that is substituted with negative 2. Right, so we'll have something like negative 2 minus that one negative 2 to the power of 3 over 3. All right, so we have something like this. All right, so we have to press the calculator. So 8 minus 8 over 3 minus will be that one in negative 8 plus with 8 over 3. All right, so we'll have something like 10 2 over 3. All right, so the answer is actually 10 2 over 3. All right, so or you can write as 32 or 32 over 3. Because it is area, so it should be units square. All right, so this is actually the area units square. All right, so this is for the first one. All right, so now that one is for the first question. Let's look at the second question. All right, so now we have this this graph. All right, so firstly we have to find, we have to know where it is bounded from. All right, from 0 until this this value which is 2 here. All right, so because this one is luckily the coordinate is given, so it's okay, you just need to directly use it. So meaning to say that you know that you have to integrate from 0 until 2, but which function to subtract which function, so you have to decide. The one at the upper part is actually this straight line which is given by y equal to 2x plus 4. Right, so that one as the upper part, so 2x plus 4 is written first. You have to subtract the one at the lower part here. All right, so the lower part here is actually the function y equal to x to the power of 3. So you have to subtract x to the power of 3. All right, so you want to integrate this with respect to x. So we have something like this, from 0 until 2 because it is bounded from this until this. Right, now you have to perform the integration. So we'll have something like, all right, so this will be 2x squared over 2 plus 4x minus x to the power of 4 over 4. We have to substitute from 0 until 2, so you can simplify first before you can you can substitute it. So you have something like x squared plus 4x minus x to the power of 4 over 4. All right. So you want to substitute from 0 until 2. So you have to substitute with 2 first. So you have something like 2 squared plus 4 multiplied with 2 minus 2 to the power of 4 over 4. Right, this one is substituted with 2, and then you have subtract with the one that is substituted with 0. So if you substitute 0 at this x, right, so you'll have 0 function there, right? So you have to subtract 0 actually. All right, so you have to show that you have to subtract 0, right? There may be some marks there, right? So 2 to the power of 2, all right, 2 to the power of 2 plus 8 minus 2 to the power of 4 over 4. So the answer is actually 8. So the area is actually 8 units square, right? So the area for R here is actually 8 units square. Okay, so that's as simple as that. All right, so next, last question here, we have this function. So to find the coordinates for a and b, all right, so there are many methods of solving this a and b. So firstly, the easiest one is to note that a is on the y axis. So when you have something, the point on y-axis, meaning to say that the x is actually 0. So when x is 0, so you substitute inside, in the function, you will get 3. Right, so you substitute into this function, also into this function, you'll get 3. Right, so at a, x is actually equal to 0, so y will be equal to 0 squared minus 4 multiplied with 0 plus 3, so it will be 3. So a is actually 0, 3. All right, so now we want to find the function for what do we call the b. All right, so the coordinate for b. So we know that at b, right, so because it is on x-axis, so meaning to say that at this value is actually y equal to 0. So you have something like y at b, right, y will be equal to 0. So because you have that x squared minus 4x plus 3 will be equal to 0. So you have to factorize this, meaning to say that you have something like x minus 3, x minus 1, right? X minus 3, x minus 1 equal to 0. So x is equal to 1, and also x is equal to 3. All right, so x equal to 1, x equal to 3. So of course, this is the value for 1, and this is 3 here. All right, so the coordinates for b in this case, right, so the coordinate for b is actually, all right, so b is actually 3, 0, right, 3, 0. Another way of solving the coordinates for a and b is actually you can equate these two function, and then you get the same answers, right, for x and y. Okay, now we want to find the area. So in this case, we want to find the area. So we note that the area is bounded from 0 until 3, right? So from 0 until 3 here. All right, so you have to integrate that from 0 until 3. So the function at the top is of course this one, because it is this that line there, right, that curve is given by the negative x squared plus 2x plus 3, something like this. All right, so you have to write that negative x squared plus 2x, negative x squared plus 2x plus 3. All right, so you have to subtract the one at the bottom there, all right, at the lower part. So of course this one, which is given by the negative x squared minus 4x plus 3. Right, so we want to subtract the whole function there, which is given by minus the x squared, all right, minus 4x plus 3. Right, the common mistake that students do is that they don't put these brackets, so that makes mistake here. Right, so we have to simplify this. So we'll have something like that one from 0 until 3, so negative x squared plus 2x plus 3 minus x squared plus 4x, and then we have to substitute with 3 dx. So we can actually cancel this part, because 3 minus 3 will become 0, and you have to simplify that to be from 0 until 3, negative 2x squared plus 6x dx. All right, so now we want to integrate this. So when we integrate this, we'll get something like negative 2x to the power of 3 over 3 plus 6x squared over 2. This one should be substituted from 0 until 3. All right, so we can actually still simplify this. All right, so negative 2x to the power of 3 over 3 plus 3x squared. from 0 until 3. So what we need to do is to substitute from with 3 first, and then we substitute with 0. So we have something like that one, negative 2 over 3, 3 to the power of 3 plus 3, 3 to the power of 2. All right, that one, when we substitute with 0, will become 0. So when you use a calculator, you get 9 units square, right, for this one. So this is the area for the bounded the shaded region R, which is bounded by the two functions there from 0 until 3. All right, so suppose now we want to integrate with respect to y, right? So usually when we want to integrate to find the area by integrating with respect to y, we have to note that the function given should be x as the subject, and it is in terms of y. Like for this case, we are given with x equal to negative y and x equal to minus y squared. All right, so we should note that firstly we have to find the what do we call that, the coordinates for a and b. So how do we find the coordinates for a and b? We know that the two graphs actually intersect at a and b, so we can equate that. We put the negative y equal to minus y squared, right? So we can bring that negative y squared to the left side, so we'll have something like y squared minus y minus 2, which is equal to 0. So we have to do factorize this, so we have something like y minus 2 y plus 1, all right, equal to 0. So we have that y equal to 2 and y equal to negative 1. All right, this one is equal to 0. So we know that it is actually negative 1 here, and also we have 2 here. All right, so the one is for the coordinates for y. Now when we want to find the coordinates for x, we have to substitute inside this or inside this. So we'll have, like, for example, when y equal to 2, so x will be equal to negative 2. So we have that negative 2 here. Right now we want this as the negative 1, so x will be equal to 1. All right, so we have that a equal to negative 2, 2, and b will be equal to 1, negative 1. Okay, so now what we want to do is to find the area for r. So we want to integrate. All right, so we know that we now integrate with respect to y. So the value on this integral should be the one on the y-axis. So we want to integrate from, you have to integrate from negative 1. All right, this is the borderline here, until 2. All right, because it is bounded here. So from negative 1 until 2. So which function to be substituted first? So of course the one at the rightmost. All right, the one at the rightmost, of course, this function, because we have this curve which is given by this, which is actually 2 minus y squared. We have to subtract the one at the leftmost, which is given by this line, which is equal to negative y. So we put negative y inside the bracket. So this is actually dy. So now we want to simplify this. So firstly, we'll have something like this one should be integrated from negative 2 until 2. 2 minus y squared plus y dy. So we now integrate this to be 2y minus y to the power of 3 over 3 plus y squared over 2. All right, so from negative 1 until 2. So now we want to substitute with the value 2 first. All right, so we'll something like 2 multiply with 2 minus 2 to the power of 3 over 3 plus 2 to the power of 2 over 2. All right, so we have to subtract the one to be substituted with negative 1, which is to be this negative 1 to the power of 3 over 3 plus negative 1 square over 2. All right, so now we try to simplify this. All right, so we'll have something like, okay, let's say we have 8 minus 4 minus 8 over 3 plus 4 divided by 2, we get 2. All right, so this one minus negative 2, that one will be plus 1 over 3, that one will be plus 1 over 2. Right, so now we press our calculator. Right, so we have something like 4 minus 8 over 3 plus 2, and then we have to subtract the one with negative 2 plus 1 over 3 plus 1 over 2. Right, so the answer is actually 4/2. Right, so 4/2. All right, so 4/2, or the answer should be 9/2. All right, so 9/2. The unit is actually unit square because it is area. So this is the answer for this one. All right. So we know that for the one that is integrated with respect to y, we should have the function at the rightmost to subtract the one at the leftmost. All right. So let's look at this example. All right. So to find the coordinates of a and b, we have to equate the x here. All right. So firstly, we have to modify this because this is in terms of x. Now we want to make x as the subject, so we'll have something like x is equal to 10 minus y squared. So this is the function at the rightmost and this is the function at the leftmost. All right, so now we want to equate them. So we know that 10 minus y squared actually intersect with the y minus 2 squared. All right, so we have to expand that bracket there. All right, so we'll have something like y squared minus 4y plus 4. All right, so we collect the y square at the right side, so we'll have something like 2y squared minus 4y. 4 minus 10 will be negative 6. This one is actually equal to 0, so we try to factorize 2. We'll have something like 2y minus 3 will be equal to 0, so the factorization should be y minus 3 y plus 1, right? Something like this. So y will be equal to 3 and y will be equal to negative 1. So we note that on this y-axis for the b is actually, for the b should be negative 1 and for a should be 3 here. All right. So we have something like this. But that one is for the what do we call that? What do we call this? The value for y. Now we want to find the value for x because we need to find the coordinates. So we have to substitute. Let's say we've substituted inside this function. 3 minus 2 will be 1. 1 square will be 1. So x should be 1. All right. So for this one, negative 2 minus 3 should be negative 3. Negative 3 to the power of 2 should be 9. So x should be 9. All right. So for this one, of course, b will be 9 here. And this one should be 1. All right, so we have that a equal to 1 3 and b is actually given by 9 negative 1. Okay, so that is the coordinates for a and b. Now we want to find the area for r. So to find the area for r, we have to integrate. All right, so we know that now we want to integrate the one that is bounded by the two curves. So it is with respect to y, so we should know that the value on the integral should be on y-axis, which is bounded by this region, which is negative 1 until 3, right, which is given by this straight line here, right? So negative 1 until 3, so you put on the integral function, which is negative 1 until 3. So firstly, substitute the one at the rightmost, which is given by this function here. All right, so this is actually 10 minus y squared should be at the rightmost of the region. All right, so 10 minus y squared. We should subtract the one at the leftmost is actually given by this function. All right, so we have to write y minus 2 square. All right, dy. We know that we integrate now with respect to y. Okay, so what we need to do is actually to simplify the function before we could integrate it. Right, so we have something like this one should be equal to negative 1 until 3. 10 minus y squared minus that one should be expanded, should be negative 4y plus 4 dy. So we have something like this one should be negative 1 until 3. 10 minus y squared minus y squared plus 4y minus 4 dy. All right, so we have something like negative 1 until 3. Right, so we have 10 minus 4 should be 6. So negative minus 2y squared plus 4y. Right, something like this, dy. So now we want to integrate it. All right, so we'll have something like 6y minus 2y to the power of 3 over 3 plus 4y squared over 2. All right, so we should substitute from negative 1 until 3. So we simplify this first. All right, so we'll have something like 6y minus 2 over 3y to the power of 3 plus 2y squared from negative 1 until 3. So firstly, we have to substitute with the value 3. Right, so we have something like, okay, 6 multiplied by 3 minus 2 over 3, 3 to the power of 3 plus 2, 3 to the power of 2. Right, we subtract the 1 should be substituted with negative 1. 6 negative 1 negative 2 over 3 negative 1 to the power of 3 plus 2 negative 1 to the power of 2. All right, so we have to simplify this. All right, so now we calculate 6 multiplied by 3 minus 2 over 3 of 3 to the power of 3 over 3, and then plus 2 3 to the power of 2. All right, so this one should be 18. We should subtract the one that is at the back there, negative 1 plus 2 over 3 plus 2, so that one should be negative 10 over 3. All right, so when we calculate this, so we have 18 plus 10 over 3, so we have something like 64 over 3 is the answer, right? 64 over 3 units square. All right, so we have the last question here. All right, so suppose we have this region. All right, so now we want to find the coordinates for A. So we know that x is equal to 6. Of course, x is equal to 6 here. All right, so x is equal to 6. So to find the coordinates for y for A, somewhere around here. All right, so we have that we have to substitute inside this function, right, because it passes through A. So we have something like y equal to, when x is equal to 6, all right, so 6 minus 2 plus 1, the 1 square root 4 plus 1 would be 2 plus 1, and the answer is actually 3. So the coordinates for A is actually 6 3. All right, 6 3. So now, all right, so we have 3 here. What we want to do is to find the integration, because we need to find the area for R. So we note that the function at the right side is actually x equal to 6, and the one at the left side is given by this function. All right, so this is given by this, but now y is the subject, so we have to modify this to make x as the subject. So what we have, that something like y minus 1, which is square root x minus 2, which is equal to y minus 1, right? So now we want to remove that square root, so we'll have something like y minus 1 square. So x is actually equal to y minus 1 square plus 2, right? Something like this. So we can actually modify this. All right, we modify this, so we have to simplify this because we want to use it in the integration later. All right, so we have something like x is equal to, you expand that, it will be y squared minus 2y plus 1, and then you have plus 2, so this should be x squared minus 2y plus 3, right? So we note that the function at the left side is actually given by x equal to, sorry, that one is y squared, right? So y squared. This one should be y squared. So we have something like y squared minus 2y plus 3, right? So now we want to integrate from, we have to look at the integral values on the y-axis. This one is y equal to 1, so 1 from 1, all right, until 3, because this is the line here, right? So 1 until 3. So from 1 until 3. So we want to integrate from 1 until 3. The function at the right side is, of course, x equal to 6. So we substitute with 6 minus the one at the left side should be this function, all right? Or given by this, all right? So y squared, all right? Y squared, please put in a bracket, y squared minus 2y plus 3, all right, dy. So we can actually simplify this, all right? So we have negative from 1 until 3, 6 minus y squared plus 2y minus 3 dy. So this one should be from 1 until 3, that one 3 minus y squared plus 2y dy. So now we want to integrate this. So when we integrate, will be something like 3y minus y to the power of 3 over 3 plus 2y squared over 2 from 1 until 3. So we have to simplify. So it will be 2y minus, sorry, 3y. That one should be 3y minus y to the power of 3 over 3 plus y squared from 1 until 3, right? So firstly, we have to substitute the value 3, all right? So it will be something like 3 multiplied by 3, 3 to the power of 3 over 3 plus 3 to the power of 2 minus, right? The one that is substitute with 1, 3 minus 1 over 3 plus 1, something like this, okay? So we can actually perform this using a calculator, all right? So 9 minus 27 over 3 plus 3 square, All right, so we have 9 minus that one should be 3 minus 1 over 3 plus 1. So that one should be 11 over 3. So 9 minus 11 over 3 will give us 1 over 3, or all right, we have 16 over 3 units square, because it is the area, right? So the answer for this one should be 16 over 3 square, a unit square. All right, so that is as simple as that. We have to have the function at the right side, which is in term of y. All right, so x as the subject, and the one at the left side is this one, x as the subject, and this is the function in term of y, and we subtract them together, and we note that the integral values for this one, 1 until 3, should be on y-axis. Right, so that's it for the area. So I hope you enjoyed the video and get what is need to be done to find the area using the integration. So that's it. Thank you for watching.